Hi everyone. Yeah, I hope you are doing well. Excited to be here. I mean, remotely, but still at ReactNative London. It's actually my first time because I'm actually based in Paris, France. I'm a tech lead at BAM. We're a company that develop mobile apps. We do Kotlin, Swift, Flutter, but of course React Native, and this being a React Native meetup, I will talk mostly about React Native and specifically on the subject of performance. So why performance? Well, one question that I feel comes up a lot with React Native apps is, what's the performance of a React Native app? How do I know, like, is it as good as a native app? How do I know it's going to be as good as a native app? I'm working for a client at the moment who has many apps, both native ones and React Native ones. So of course, you know, that question comes up a lot. And, you know, we can say, well, you know, the app feels fluid when you play with it. It feels nice and all, but it'd be nice to have actual data to prove this, right? It would be nice to have some kind of measure and establish, well, okay, here are the numbers, here are the facts, the app is good. So we can ask ourselves, scientifically speaking, what does it mean that my app is fluid? Well, Google answers this by saying you need your app to run at 60 FPS, 60 frames per second. There's a good video to explain that. The link will be available, of course, in the slides afterwards. But I'll just share the gist of it. Basically, it says that motion in a video, for example, or in your app in an animation, it's just an illusion, you know, it's created by quickly changing static images at a consistent speed. The speed here being 60 images per second, 60 frames per second. So on most devices, 60 is good because it's fast enough for good perceived smoothness. When you do an animation, it feels fluid enough. There are less perceived benefits in higher numbers, even though we're getting a bit more devices running at higher FPS now. And also one thing that is essential to remember is the frame rates should be constant. So if you get 60 a lot of the time, but then you go down just to like 55 or 50 once in a while, it's very uncomfortable for the user because it feels laggy. This is lag. This is what it feels to have some lag. It's even better, I would say, to have like a lower frame rate that is constant than actually have a higher frame rate that you're not able to meet. So the question we can ask ourselves is, how do we get this? How do we measure this? How do we get this measure? The good news is, for an Android app, and if you're developing in React Native, I'm assuming you've used the Play Store before. Actually, the Play Store kind of reports it already, which is nice. I encourage you to explore the Android Vitals section of the Play Store. It's amazing. You have a lot of data there, and I was like, okay, well, let's see how we are doing. And here it is. You get the stat, which is called slow UI rendering. It's probably small, but I'll just read it. It's the percentage of daily sessions during which more than 50% of frames took longer than 60 milliseconds to render. It usually gets me a bit of time to say this and to wait. What did they mean? But basically it says this, it's the percentage of daily sessions during which more than half of the frames were laggy because they were not able to display 60 of those images per second. That didn't mean the 16 milliseconds deadline, because 1 second divided by 60 equal 16 milliseconds. So basically it means it's the percentage of daily sessions with significant amount of lag. And we were at 23%. So that's kind of horrendous now, isn't it? That's not really what we were expecting, to be honest. And the Play Store compares you with your peers, usually in the same category as yourself, and we're 10% over the peers. But even our peers were actually very bad, because if we compare ourselves with top apps, we're just better than 6%, and you'd have to be at below 4% to be in the top 50%. So, okay, well, let's see how we are doing. We're doing really bad. That's that's the gist of it. All good, cool. Well, now we have a measure. We know we're doing bad. The question that you could ask is, what about iOS, right? On iOS, the best way I found, so there's nothing like that. I feel like the Play Store has a lot more data than App Store Connect or iTunes Connect. But on iOS, you can install Firebase Performance on the app. Actually, yeah, sorry, wanted to say this first. So I was kind of brainstorming at this point and telling myself, what are common performance issues that we could have? And usually large images is a big issue, or excessive React renders, but we had some tests for this and it didn't seem to be the case. I was like, well, maybe it's the user's fault. Maybe, we cater to too many people. And and maybe some users have like very lower end devices, and that's why it's not working so well. Okay, that's a bad thought. We should still, especially if our market is catering to lower end devices, we should track those issues. But actually, the Play Store just counteracts that, because the image is kind of small, but this was saying you can check on all devices what are the stats. And on an S8, Samsung Galaxy S8, the stats was 25% of session with lags. Samsung S8, 25%. Samsung S8, top of the line 3 years ago, expensive 3 years ago, expensive device 3 years ago. It was like, okay, well, we definitely have a problem. And on iOS, so installing Firebase Performance, as I was saying before, didn't have such an issue. So Firebase Performance, if you have ReactNative Firebase already, very easy to install, and it gives you the same stats, and we had only 0.15%. Okay, that's kind of a victory. We were pretty good for iOS. But big issue on Android again. So the question is, what is this issue? Generally, in terms of performance, what you want to check for a React Native app is whether your issue is native, on the native side, so on the UI thread. So it's the thread that is supposed to be calculating everything that needs to be drawn under 16 milliseconds, versus the JS thread, because the JS thread is actually driving the native components, and it needs to say, ideally every 16 milliseconds, hey, you need to render this, hey, you need to do that. Usually your best friend to check this is the performance monitor, available out of the box on React Native. You just open the development menu by shaking your device off or Command D, and you get this nice window. And especially you get UI and JS data. And here, well, you can see that the data is not good. It's supposed to be 60, and it's actually 24 in this case. Just a note, given the way the JS thread, the JS frame per second is calculated by React Native, usually if your UI thread is low, the JS thread will be low as well. So if the UI thread is at 24, the JS thread can be at most at 24. It's just given the way it's calculated at the moment inside the core of React Native. But in our case, JS thread seemed to be good, and the UI thread was kind of laggy. Actually, this is not the this was not real in our app. It was not as bad as this, but it was more like 50-55 from time to time. But we kind of assumed that it was just when we were on the debug mode, etc. But yeah, that's it. But it seems like we had an issue on the native side. So we can use also native tools to measure this. On Android, we can use ADB. A nice comment here, ADB shell dump sysjfx info, and the bundle ID of your app prints out a lot of information about a session. Really interesting to dive into that. Especially gives you the number of frames rendered and the number of frames that did not, that missed the 16 milliseconds deadline. In this case, 24 frames, but actually 5 missed it. So in our case, yeah, giving that, we could easily see that we had some issues, and they seem to be on the native side, and specifically on Android. The question is now, how do we debug this? How do we handle this? You know, on the JS side, we have the Chrome performance profiler, but on the Android side, I don't really know. So let's investigate. And the best thing on for native apps on Android is to use SYSTRACE, short for system trace, or at least that's what we used. If you have the Android SDK, well, of course you have it. You know, you're developing an Android app, hopefully, if you are using ReactNative, and it's available out of the box. It's Python scripts that you run, and you give it a time to run. It's going to print out a report of everything that's happening. So you run the script, you do stuff in your app, and it's going to print out a very detailed report of what's happening at a very low level inside your app. This is the buffer size. This is saying my HTML cannot go over 100 megabytes. And yeah, actually, the HTML generated is very big. Well, let's dive in, actually. Let's see, you know, I was like, okay, given this, I'll start with just opening my app. So running SYSTRACE, so this script exactly, just opening my app. So my app, it just opens home feed with lots of content, and see what it gives me if I already have some issue there. So let's see what this gives me. This gives me something like this. It's beautiful, right? It's kind of daunting at first. Very colorful file. And you're expected to navigate with SW DA keys to just navigate, zoom in, zoom out. It's pretty crazy, actually, what you see here, and we'll get to that. But first, let me just zoom in a little bit so that you see better. On the left side, you can see a lot of stuff. Especially, you can see my app, which is of course your bundle ID. Well, in this case, it was the bundle ID, and whoop, you can yeah, you can see a lot of information. You can see threads that are running. You can see some, you know, some old friends like MQTJS. That's actually the JS thread. So you can actually check out if a lot of stuff seems to be happening on the JS thread. You also have MQT native modules. This is the thread that is used for native bridges. If you write a native bridge, or any native component in React Native, it will run by default on this thread. You can also see OK HTTP dispatch. If you use fetch, that's available out of the box in React Native, you're going to see activity for API calls. And Fresco, if you use images from React Native, Fresco is the native library that React Native uses to display images. So we were talking about large images before. If you had large images causing issues with your UI thread, this would be, you would see a lot of activity here, which was not our case. So I was saying what interests us is the UI thread, right? So let's check the UI thread. And indeed, there seems to be a lot of stuff happening. And one thing interesting is we see those Fs, a lot of Fs. all over the way. And we see green Fs, we see red Fs, and we see orange Fs. Well, you know, it's next to frames, so yeah, it's no, it means frames. and basically what it means is green means that the UI thread was able to calculate everything that needed to be calculated to render the frame under 16 milliseconds. So you can see that, okay, yeah, this is green. And yeah, there's not a lot of stuff on the UI thread. The UI thread is not very busy during that time frame. Yeah, by the way, on view options, you can highlight the 16 milliseconds frames, which is very useful. It's just, you know, nicer to look at. So yeah, green Fs mean good to go. Okay. Orange F means, well, probably I won't make it. And red Fs means, wow, this is way too heavy for me. I don't know if we get, you know, a red F, you can see that, yeah, there's too much stuff. Actually, you can even see that the F should actually be here. The F should be just on the, like it should be at the beginning of the how do you call that? The new gray color. So there's some delay because there's so much stuff to be calculated that it's just getting late. Is every 16 milliseconds, it's like it's taking more than 16 milliseconds to calculate each frames. So it's just getting more late and late. So this is lag. This is lag at a very low level. This is what it means to have some lag. And yeah, we have a lot of red, don't we? We have a lot of red here at the beginning, and we especially have a lot of red here at the end. So, and this was just me opening the app, just opening the app. Awkward, right? So yeah, lots of issues, and well, let's dive in. Let's see what those are, and let's start with those big red Fs here at the beginning. So we can check what the UI thread is doing, because this is what interests us, right? So sometimes when you click, you get some nice explanations over what it's actually doing. So choreographer do frame, this is like the lowest of the lowest level inside the Android OS. It's basically the stuff that's responsible for saying, okay, every 16 milliseconds, I have to do this. I have to recalculate everything and redraw everything. What it does is it calls traversal. Traversal just, well, it's not explained here. It just goes through your tree of components, native components, but usually, I mean, it's going to be the same as the React component that you have, because they're driving native components. And it needs to decide for each of them whether, so this is in the draw method, in record view draw, it needs to decide which of the components need to be redrawn. So it needs to check what changed and what needs to be redrawn again, and then execute the draw function. So, okay, here we can see basically, so, you know, do frame calls traversal, traversal calls draw, draw calls record view draw. So if draw is big, then traversal is big, because here it's the beginning of traversal, and then draw is called, then draw reports back to traversal. So that's why both draw and traversal are big, but that also means that the issue is with draw, right? There's too much stuff happening in draw. But that doesn't tell us a lot, right? We know basically on a low level that the UI thread is busy drawing some stuff. It doesn't really tell us, what it is drawing. But here we have an interesting guy, right? We have the render thread that we haven't checked yet. So what's the render thread? It's kind of the little brother of the UI thread. The render thread runs on the GPU of the device, and it runs in parallel of the UI thread. And the UI thread can just send, after the record view draw function, it can send some expensive calculation to the render thread because it runs on the GPU. So it's going to be, it's going to have better performance. It's especially useful when you have animations on the native side. It's used for translation animations, for example, etc. All the animations, basically, when you set use native driver to true in React Native, it's going to run on this thread, and that's why they perform so well. And it's the same with reanimated, actually. There are some animations like translations, etc., that will run on the render thread, and height and stuff like this that will run on the UI thread. But it's still better than the JS thread. So basically, the UI thread sends some calculation to the render thread. And the render thread seems to be pretty busy, and it needs to report back to the UI thread. So the UI thread tells the render thread, hey, calculate this for me, but report back because I need to print out something under 16 milliseconds. And here we can see that the render thread is actually very busy. So the UI thread is like, well, come on, I mean, I have to meet my deadlines. But here we can actually see that the real culprit is actually the render thread because it's doing a lot of stuff. And in this case, we're pretty lucky because if we zoom in, we can actually see that this is caused by Lottie animation view. Because, yeah, this is quite big, right? This is super big, Lottie animation view. We can see that every time Lottie animation is super huge. And, well, there's a bunch of sub-functions being called. And it's crazy. And yeah, actually, when we open the app, one thing I haven't mentioned is the first thing you see is a splash screen. It has a nice Lottie animation. It's really beautiful. But then it also blocks the render thread and thus the UI thread for a lot of time. So it's responsible for lag and bad performance in the device. I won't go into too many details over how to fix that. Lottie has actually kind of a nice documentation. So if you have issue with Lottie, they have a nice documentation about Android performance. Essentially, we needed to run the calculations on the UI thread instead. They have a good documentation to explain why in some cases it's better to run on the UI thread than on the render thread. But at least, that was one of our problems solved, because if we come back to the big view, the first red Fs, it was all Lottie animation. Okay, woo, cool. Okay, so that's one issue down. I'm especially interested in those guys here because they're really big and it's a lot of red Fs. But one thing to mention is we open the app, a lot of stuff is happening. There's a splash screen, there's the home feed loading the whole navigation, putting itself in place, etc. If you want to know, what's happening, kind of putting markers of like, okay, this is Lottie, this is whichever card that is rendering, you can actually do that. Natively, you can call a method debugged.trace to put some custom marker here. And I don't know, for example, if you want to see, okay, transition, you can just call debug.trace and say start transition and then end it at stop transition, and you can check, if maybe some transition is actually affecting a lot or what is really going on when you do the transition. But sometimes you also have nice markers available out of the box. For example, animator. I was, really wondering what was up with that. Animator rotation, animator. I was like, there is no animation. I mean, we had the Lottie animation, but that's done, right? That's over. It stopped here. And so what is this? What is animator? Turns out it was actually the loading spinner of the home screen. So it does this, and this is basically the duration of the loading of the content and the displaying of the content, which brings out this orange, but maybe not our biggest priority at the moment, because what's a bit more concerning is that here the loading is finished. We've displayed everything that needed to be displayed, and yet we just have red Fs. Like, what is wrong with that? we only have red Fs at the end. And to be honest, the ad wasn't doing much. We've already displayed the content. We've already displayed what needed to be displayed. So what was happening? So we can check again UI thread. And we see our, the same friends as we had before, do frame, traversal, blah, blah, blah. And render thread, draw frame, flush, drawing comments, blah, blah, blah. But it's very low level functions. I don't really know, to be honest, what each EL swap buffers with DMHKHR is really doing. But there's no explanation. When you Google that, you usually have like the Android source code or whatever. So it doesn't really help. We can check out other thread to check, what they're doing. We can see that the JS thread is not doing anything, right? It's not doing much. So culprit is not the JS thread. There is nothing happening on the JS side. So yeah, kind of tricky. But one thing that we haven't checked is this at the top. This is really interesting. It's what each of the CPU of your device is actually doing. This was very low level device, a very low end device actually, but still it had 8 cores, quite impressive for a 50 euros device. But yeah, you can check what each of the CPU, is doing, which tasks they are running at any given time. You might recognize some stuff. Okay, the render thread, all over the place. We kind of knew that. You see also Google Tag Manager running a lot. The pink one is always Google Tag Manager. It seems to be keeping the CPU a lot. But actually, there's a good way. I mean, there's a nice way to go over this. You can just select a rectangle of just like this, of everything that the CPUs are doing, and then you get a nice list of all of the tasks that are run. Don't worry, I have no idea what each of those tasks are, but what's interesting is you can sort by wall duration, and you can see, yeah, the render thread is keeping the CPU busy a lot. We knew that, right? We knew that, yeah, we've seen this. The UI thread was busy, and it's the same as the Lottie animation. The UI thread was busy because the render thread was busy. Question is why? Well, what makes it busy? Because it's not the Lottie animation. There's no Lottie animation anymore. Second one is compositor. I didn't really know what that was. And the third one is Chrome. In procre, don't really know what that is, but seems to be related with Chrome, right? And actually, just if you search a little bit, compositor is actually related to Chrome as well. It's a task that is run by Chromium. So the question was, it's a native app. Why do we have Chrome running? And why do we have Chrome? It seems to be a big task. Yeah, it seems to be keeping the CPU busy a lot. Probably that could be the cause, right? And it's a native app, so I mean, it's a React Native app, but these are native components, so why would we have a Chrome? And actually, it turned out that on our home feed, we are displaying ads. We are displaying ads with AdMob. It's an SDK available in Firebase as well. And AdMob, essentially, it's a native SDK that wraps web views. And depending who implements the ads, they can be, they basically can be anything they want. So you don't have much control over what goes onto the HTML. So in our case, the ads were actually custom and implemented by a company for our client. And it turned out that, yeah, along the lines, the dev didn't get the message that these were ads for mobile. So we actually had desktop ads running in the model, and we had like huge images, like I'm talking 3,000 by 3,000 images that needed to fit in a 50 pixel high frame. So in terms of performance impact, this is actually insane. This is crazy. Like first 3000 by 3000. It means that in RAM, in memory, it's usually four bytes per pixel or so. So this means you have 3000 per 3000. So that's 9 million. Before, that's like 36 megabytes of RAM per image. And we had a lot of ads, actually. We had a few ads just at some different position in the home feed. So this was actually impacting memory usage a lot. And this was, of course, impacting CPU a lot. Anyway, we just, yeah, we got them to make ads suitable for mobile devices with much smaller images, also less JavaScript because a lot of JavaScript was running. And the result was, of course, much better because, so this is fixing the loading animation and fixing the ads. Yeah, I mean, nothing much is happening anymore. So of course, and yeah, we see a lot of green now everywhere, a little bit of red and orange, but to be honest, I was already pretty happy with this change, sorry. Yeah, much better than before. So woohoo! Okay. Whew. So that's basically pretty much I wanted to show you guys, is how you can dive deep into, well, with SYSTRACE, into what the OS is actually doing on a low level, and you might actually learn a lot of stuff about what is happening under the hood with your app. And yeah, to conclude, yeah, what are your 60 FPS stats? I mean, you have the Play Store, go ahead and check what are your Android vitals and brag if you're in the top 10%. And I would be really happy if you hit me up on Twitter to say, hey, we're doing much better than you are with our React Native apps, just to show the world that React Native apps can have really good performance. I encourage you to install Firebase Performance. Gives you a lot of insights over not only FPS but also low latency in your network, or app startup time and stuff like this. It's really nice. Oh yeah, just a quick thing to mention. So I talked a lot about the UI thread, but of course, in React Native apps, the JS thread is often a bottleneck. We're working at BAM on something that should be a Flipper plugin, but something just to give a measure, a better measure when you're developing on a day-to-day basis over is what I'm developing good or not, basically, in terms of performance. So if you want to know more about this, just same thing, hit me up on Twitter or ask questions. And yeah, that's it for me. Thanks a lot for your attention. And do you have any questions? I think, yeah, Alex.
Yeah, thank you so much, Alex. We don't have any questions yet, but I'll just give everyone a couple of seconds in case they want to add any. But I was just wondering, like, how often do you have to use SYSTRACE? Like, how often do you find a problem is worth diving into this for?
Yeah, that's a good question. To be honest, this was the only time. Although, no, not the only time. We also had an issue with app startup time. On Android, it was especially high. So we have an app with like 60 screens or something like that. And this was really nice because you see everything that's happening during the app startup time. And we could analyze a lot of issues that we could fix. A lot of stuff that were blocking the UI thread, actually, that could be delayed. For example, ads initialization.
Yeah.
But yeah, it's nice. But to be honest, yeah, I don't use as often. It was kind of a weird case where usually you have an issue with the JS thread and you profile it with Chrome or something like that. But here it was not in the JS side.
So what's the trigger for you to know to look at the UI thread? Is it like fairly obvious when you have a problem like this, or are there any like telltale signs?
Well, usually I look at the performance monitor. This is also kind of what we want to achieve with the Flipper plugin, is just something to just tells you, okay, well, you had the UI thread was good, the JS thread was bad, investigate the JS thread or something like that. But yeah, usually with the performance monitor, you can see which one is blocking. But actually, SYSTRACE is also a good way to check which one is blocking, because you see both threads, and you can see if, you know, the MQT JS, it's the JS thread. You can see that if it's doing a lot of stuff, and if it's causing latency issues or not.
Okay, cool. Thank you so much for giving a talk. Hopefully we'll have you back again, not too far in the future. Next up, we've got Sébastien talking about using React Native across platforms. So Sébastien, if you just want to present your screen and take over.
Yeah. Wait a minute. Is it okay? It's working?
Yeah.
Yeah, okay, thanks. So, hello, I'm Sébastien Lorber, and I'm going to talk to you about ReactNative, Jamstack, and a bit more. So I'm a ReactNative developer, and I work currently on Docusaurus as a freelancer for Facebook. So you maybe have already heard of this project because it's the one that powers the documentation of websites like ReactNative, Jest, and many other projects from the React ecosystem. I'm not going to talk about Docusaurus today, but maybe it would be interesting for another talk. The talk is about the story of my blog. 3 years ago, I wanted to have a blog because I was a developer for a long time and still didn't have a blog, and I wanted to be able to write technical articles. I also wanted the blog to be interactive because I think it's cool to have embedded code samples and being able to play with them, and wanted the blog to be somehow a kind of a sandbox where I could try new technologies that I like. And the thing is, at this time, I've heard about React Native Web, which is a technology that was created by an engineer at Twitter. So basically, the idea is to be able to create a website with React Native, and it's been adopted by Twitter, Uber, React Native directory, which is where you find the React Native libraries. It has interesting properties because it permits to do atomic CSS and JS. I've written a blog post about it if you are interested to know what it is exactly. But the idea is that each CSS role that is in the DOM only has a single class, and as the CSS roles are reused across the website, this makes the CSS file scalable because it doesn't increase too much as the number of components increase. So this is a technology I really wanted to try on my blog, and I thought it would be possible to do so. So I had a very ambitious blog project where I wanted to use all the technologies at the same time. But the thing is, this was a bit too much, and I mean, I was thinking about issues, integration issues about all these technologies, and finally I didn't write anything, and I still didn't have a blog. So 2 years later, I decided to just stop doing that and create a Gatsby blog from a template where I just would have to create markdown files to be able to publish something. And I finally ended up with a term novella to create my blog and write my first blog post. So it was not a total failure because I still wanted to use React Native Web, and the talk is about although the creation of the React Native Web plugin for Gatsby. So during this time, I created this plugin and was able to integrate it back in my website in the Gatsby template that I chose. So it worked nicely. So in this talk, we will see how I've managed to get it working on Gatsby, and this is the first part of the talk. So first, what is Gatsby? It's a static site generator. It's based on React and is an SPA framework. So basically, React is not only used on the backend on the Node server to generate the pages. There is also the React integration in the front end, so you can run any dynamic code on the front end too with the power of Gatsby. And it also has a first-class integration with MDX. So we'll see what is MDX later. Some details about ReactNative Web. Somehow, I like to consider ReactNative Web like a CSS in JS framework that reuse the abstractions of ReactNative. So basically, there are two. Somehow, it tries to convert ReactNative to React DOM, and it does so with a Babel plugin. So, for example, if you have imports, view, and text from ReactNative, the Babel plugin will rewrite these imports to ReactNative Web. So this is pretty simple. And there is also custom implementations of the views and text and ReactNative primitive elements using DOM primitives. So basically, it's just replace the primitives of ReactNative with primitives of ReactNative Web at the build time. And the primitives of ReactNative Web are based on the React DOM primitives. So the ReactNative Web implementation keeps the properties of the ReactNative, like for example, everything is flex, and by default, the flex direction is colon. But you can override it, but all the views in ReactNative Web will always be flex because this is how it works in ReactNative. So how can we integrate this with Gatsby? So Gatsby, we have to be able to render ReactNative Web on the server. And somehow it's quite similar to the integration of any CSS in JS library on server-side rendering. So basically, you render the application, you obtain the HTML, and the library also permits to extract the CSS that was used during the rendering of a given page. And then you can put the critical CSS in the page and the HTML marker and write the HTML file on the file system. So here is an example of a Gatsby page using ReactNative Web. So we see that there are views and text and touchable opacity. This is the first thing I tried to do on Gatsby. And this leads to this result where we can see that there is a Gatsby page with a button. So this is what we expected. It's not very pretty, but at least I was able to get something working. So now let's see some details. Here, this component is a ReactNative component. We can see it only use ReactNative components. It uses touchable opacity and text. So the thing is, as it only uses ReactNative components and we are able to translate ReactNative to React DOM thanks to ReactNative Web, this component is cross-platform, and by that I mean it is able to run both on mobile and on the web. But now let's see another example. This is a Gatsby page. We can see that it mixes both ReactNative and React DOM primitives. But we have a way to convert ReactNative primitives to React DOM, but we don't have a way to convert React DOM to ReactNative primitives. So this is not cross-platform, and this will work, but only on the web because we don't have a way to render a div and a header on ReactNative. So now let's see what is MDX. MDX is a very popular Markdown compilator. Somehow it's an extension of Markdown in which you can put React components in it. And it permits to create interactive blog posts. For example, it's very popular across the Gatsby ecosystem and the Next.js ecosystem right now because it allows you to embed interactive code inside the blog post. Unlike other alternatives like Code Sandbox and things like that, you don't have to use an iframe. You really embed the React code directly in your blog post. So this is interesting to build interacting content. There is also plain support for Vue and Svelte, but I don't know too much about this, so we'll see later. So here is an example of Gatsby, ReactNative Web, and NDX. We can see at the top a component using ReactNative. I mean, no, it's a blog post. We can see that it's an NDX file with Markdown and a button in it, and we are able to import this NDX file in a Gatsby page, and this works because there is a Webpack loader that is able to convert the MDX file to a JSX component at build time. So if we look what is the result of this experiment, we can see that we are able to get the blog post running inside the Gatsby page. So somehow you are able to embed MDX content inside a Gatsby page if you want. Maybe you can have a section being one Markdown MDX file, another being a second MDX file, and compose multiple sources into a single page, or do many things like you want. Somehow an MDX file is like a React component. So this is the first version of the plugin I was able to get working. So I was very happy because the proof of concept was working and integrated with Gatsby. So basically, if you render it on the server, it permits to have good SEO support because it outputs a static website. So the ReactNative text and things like that are really able to be crawled by Google. And it's also performant, secure, and very easy to deploy to Jamstack hosts. But there were some limits. For example, there is no WebJS extension, so you can't easily add web-specific components. So if you want, for example, to have a view that is that you usually query or whatever, if you want, you can't. Although in this example there are no libraries, so there is something particular in the ReactNative ecosystem is that all the libraries are published transpiled. So I mean untranspiled. So if you want to use them on the web, you have to transpile them directly on your app because it's not done for you automatically. There's also no dev annotation that you can use in mobile. There is no support for export modules and things like that. So the POC was working, but it requires a bit more config. Sorry, I'm opening the. I think you maybe see me later. So I continued to experiment with this plugin. For example, I tried to create a version 2 where I supported various ReactNative libraries, for example, ReactNative Paper, and things like that. This was working. I built some interesting demos that worked, but it was still a bit limited because the libs that I transpiled were hard-coded. So for example, if the lib was not in the list of the plugin, then it didn't work because it wasn't transpiled, and it will require a bit of setup to make it work. So I wanted the plugin to be more plug and play, and this is where Expo comes in because maybe you know that Expo has worked to bring a good web support to their SDK. So somehow I see Expo as an extension of ReactNative Core because it contains much more APIs like video cameras, fonts, and image picker. You know that ReactNative Core is lean now, so most of these kind of APIs are out of the core. And Expo has tried to publish web support to many of their components. So basically, it's possible to use them in Gatsby. And there's also something else that they published, is that they published their toolchain to be able to bring Expo web support through Webpack. So there is a package named Expo Webpack config. And basically, if you have a project where you want to try React Native Web, you can use this config. You take your original Webpack config, and there is a method that permits to wrap it so that somehow it adds automatically the Expo support, so that you can use React Native Web and Expo modules in your web app. So this is pretty easy to set up right now. And Expo does the heavy Webpack work for you, so that most of the ReactNative ecosystem libraries that support the web are able to work on UI. So now let's see if we can get MDX blog post using an Expo component. For example, the video component of Expo. We can see that it's a Markdown file with a React component embedded in it. And if we try to render it with Gatsby, we can see that this works, and the video, the interactive component, is able to work fine. So I have a few demos. For example, ReactNative SVG works fine on the web. So if you have an SVG defined in ReactNative, you can also render it on the web. There's also the Expo camera component that works fine. So this is another example. There is this demo that uses ReactNative gesture handler. Maybe it's laggy on the stream, but in reality it works great. It works fine. And another example is Expo image picker and manipulator, so you are able to manipulate if you want to, and all this works fine. Another example that is interesting is Expo dark mode switch. I think it's interesting because this is not a library that is part of the official Expo SDK. It's a standalone library that Evan Bacon from Expo published. And the thing that is cool is that it works both on mobile and on web. And they also built some kind of some utils to be able to publish such library. So today it's quite easy to be able to publish a library for both web and mobile in ReactNative without having to do too much scripts and Webpack, rollup, and things like that. You don't have to touch all that to be able to publish a library. This component only use ReactNative primitives. So, for example, the animations are using the animated framework and the image components and things like that. So the takeaway of this is that ReactNative plus Expo has good web support. You can use it on the Jamstack and have good SEO. And it's not very risky because you always have the .web.js extension fallback. So if you want really to have an escape H and use whatever JS code that works on the web you want, if you want to use jQuery or Backbone.js or whatever, you really can. It's possible. So I don't have a very much use case for it, but I guess the most classic one is to be able to reuse a design system that you created for ReactNative and maybe publish a mobile website or a marketing website using the same design system. So it's your turn to figure out which components you want to share between web and mobile, but I'm sure that there are some that you'd like to be able to share. So this is the first part of my talk. Now I want to see if we are able to run MDX in ReactNative. So let's take, for example, an example blog post. So this is a post with a title and a React component in it. We will see how MDX works exactly. The first step is to be able to transpile the MDX to JSX. This is part of the MDX compilation process. So once you feed the MDX transpiler with MDX blog post, and as an output, it gives you something like this. So basically, it transforms a Markdown document into a React component. And then there is another step that is done for you by default by Metro. It's the transpilation from JSX to JS, because you know that JSX is can't run in the JS engines directly. So here it's the final result of the transpilation process of a blog post. And there is something interesting that we see is that everything is using DOM primitives. So for example, you can see that there are divs, H1 and P elements. There is no ReactNative elements. So the question is it possible to run this on ReactNative? Somehow we need the opposite of ReactNative Web, so to be able to convert DOM elements that are the output of MDX to ReactNative so that it is able to run. And there is a solution to this problem. MDX has something called MDX provider, and also there is the GSX pragma. I'll explain later how this works. There's also an interesting project from Expo that is HTML elements, but I didn't try it yet, so I don't know if it will be a good fit for this idea. So let's see how the GSX pragma works. So there is in the Babel plugin that transforms GSX to JS, there is an option that you can use that is the GSX pragma. So basically, you have an opportunity to tell the Babel transpiler to use something else than the React create element calls that are done by default. So the idea is that you put this annotation at the top of your file, and it references an import of your file, and then the function of this import will be used in place of the React create element calls. So now, if we look at the new output, once we apply the pragma, we can see that the GSX function is called instead of the React create element, and it's a function that is imported from the MDX package. So this is the first part, and is required to get the MDX provider working. And the MDX provider, once we have wired the GSX call for the pragma, is able to allow us to override the elements that are output by MDX. So for example, if we encounter a div in the GSX output, we can say that for ReactNative, a div should be rendered with a view. For example, the anchor element, we want to display it as a link. So basically, how we render a link in ReactNative, it's not with a element, it's with a text. And when we press on it, it uses a linking open URL. So somehow this is the opportunity to convert from ReactDOM to ReactNative in the opposite sense. If we look at the result of the transpilation of the blog post, how can we use this? We can actually directly import the output of the GSX component in a ReactNative app, and we applied the ReactNative MDX provider that we created so that it replaced the elements, and we get this result. So we are able to render the Markdown document on ReactNative. But the question is, this is a proof of concept and is working. But can we run a real blog post, for example, a blog post that I've written, and I wanted to see if it was possible to render it on ReactNative. And I tried to do the same thing that I did just before with this blog post, and obviously it didn't work. This is because the most common errors I got was that there were missing conversions from DOM element to ReactNative. So if any conversion is missing, you end up with ReactNative trying to render DOM elements, and this doesn't work. And also there is the very famous issue where you try to render text without wrapping it in text element, and then you have a crash of your Android app or things like that. So what we have to do is to provide a full mapping of all the DOM elements that are output by the MDX compiler, and take care of wrapping each piece of text in a text element and things like that. So this is a bit a bit annoying process to support all that, but once it's done, it works fine. So there is another issue that I had with images, because on the web, when you use images, you expect to be hosted on the site, and in ReactNative, it's not exactly the same, because you you generally put the images in a folder and you require them. So in the output of MDX, it doesn't require the images elements that are referenced in the Markdown document. And so I created a hacky solution that just replaced the non-required images with a require call. So this is just manipulating the source code to add a require call. Quite hacky, but there is probably a better solution to this problem. And in the end, I was able to get the blog post running in the ReactNative app, but it was not very pretty yet. There is no header, image, and title, and things like that. And the thing is, on Markdown, generally, you put metadata at the top of the blog post, which is called front matter. So, for example, if you want to have a header image, tags, author, the picture of the author, the title, and things like that, you put it as metadata at the top of the document, and you should be able to render it. But this metadata is not part of the MDX specification because MDX doesn't understand these. These are very specific to your app, so we have to handle them separately. So for now, I just hardcode some front matter like that, and I just add a scroll view and try to display the hard-coded front matter so that in the end, the blog post works is able to be displayed in the mobile application. So this is nice, but there is it's just one blog post. What would be interesting is to be able to see the full blog in the and have some kind of automated process so that I don't hard code too much things to get this working. So can we automate this MDX compilation step as a real step? And what about integrating React navigation and maybe integrating it in an existing app to have other pages than blog post? So let's see how we can build a static mobile app generator. The first step is to be able to take a folder full of MDX files. For example, here I have the content folder. I create, for each of the files in this folder, I will read the file, obtain the source code as a string, and then I will transpile the JSX to a JSX string and then write it back to the file system so that in the end, we have real components in the file system that are written. The next step, I will detail a bit about the JSX string transformation. So basically, you have initially the MDX string, you add the pragma that we discussed earlier. You extract the form matter with a library that is Gramatter. It's the most popular library. For example, it's used in Gatsby too. Then you add an export of this font matter as JSON, and you compile it from MDX to JSX, and then you create a source code, the source code of the component that you require. So now we also need an index because, for example, if we have a list of blog posts, at some point we need an entry point of all the blog posts. For example, the home of the app could be a list of blog posts. So I write for each file, I write an array which requires each blog post. So basically, it will be an array that contains the components on which there is the font matter export to available. So if you look at the array at the bottom, you can see the final result of the thing for my blog. The next step is to be able to navigate between the blog posts. So for example, we will create a stack navigation using React navigation. The screen at the root of the app is the blog post list. And we also add another stack screen that is a blog post. So basically, when you press on the blog, you are able to navigate to this the specific screen for the blog. Let's see the blog post list. So it's just a scroll view that imports the generated file that contains the blog post list. And when we click on the blog post card, we should navigate to it. The blog post screen is not very much complicated ever. The blog post contains both two imports. It contains the MDX component and the front matter. So we will render the front matter separately because this is metadata very specific to our application. And then we will render the MDX component that is the rest of the markdown just under. So this gives us this result. We are able to have an application with all the blog posts running. And there's something interesting is that the interactive demos that I embedded in the blog post are also working on the mobile. So these demos are also cross-platform because they only use ReactNative primitives. And I think this is pretty interesting. So I also wired the dark mode switch to React navigation appearance and things like that, so that the time is able to change. So the takeaway is that MDX is a cross-platform technology, ReactNative is a cross-platform technology, Expo is a cross-platform technology, and I think all this enables to be able to create cross-platform interactive content, so you can create Markdown files that actually run everywhere. So another part of the talk is the CI automation. This is a small part, but I think it's pretty cool. You create scripts, JSON scripts to be able to deploy your another script to be able to compile the MDX and then publish it to Expo as an Expo app. So basically, you are able to distribute it easily and test it easily by scanning the QR code. Then you can have, for example, your CI like Netlify that is able to build your website, and you can have another CI that is able to deploy to Expo automatically. So basically, if you have a repository with a folder with Markdown files, you are able to just commit in this folder, and then your content is published both on the Jamstack site and the mobile app. But this is pretty nice. But I wanted to see if it was possible to get a bit further, and I wanted, for example, React Navigation 5 as web support, and although there is an export, there is a command that permits to export an Expo application to the web. So I wanted to see if I was able to get another platform for free, which would not be based on Gatsby, but would be a mobile website based on Expo and React Navigation 5. And basically, it just required a few tweaks of my website, of my publish scripts. So now the publish mobile command publish both to mobile, but it also published the mobile website from the Expo web support to another deployment. And I was able to get a mobile website for free like that. So the result is not as good as the Gatsby website because it's the React navigation web support is pretty rough, so you don't have any animation and things like that. But I think it's pretty cool to have it for free. So the takeaway is that I just need to commit MDX to deploy to free platform. I am able to deploy to the web through the Gatsby website. I'm able to deploy to mobile web with the Expo web support, and I am able to deploy to iOS and Android with the regular Expo support. The trade-off is that now I have to pay Netlify because I consume a lot of build units, and the free plan is over. So the last part of my talk is here we have iOS, Android, and web. I think it's pretty nice already, but maybe it's possible to support other platforms. You probably have heard that there are other platforms like macOS and Windows that are being worked by Microsoft, and there is also the TV and maybe other things that I'm not aware of. So I wanted to see if it was possible to get this running on other platforms. And the result is that I was able to create a macOS Tray app but it's it's the ReactNative macOS on which Microsoft is working on, and I was able to create a triad that displays a blog post. So this is totally overkill, but I think it's pretty interesting to get this working, and it proves that MDX is a real cross-platform technology. About Windows, I wasn't able to get it working yet, and TV not yet too. I don't know if I will have time to play with that, and as it's a bit overkill, I'm not sure to have time to do this. But the takeaway is that you can really everywhere, and it is a native, no web view, there is no iframe or whatever. It is really embedded in the content. So the blog post is using real native elements. And I think ReactNative macOS and Windows are ready to try and pretty stable already. So I think it's really time to get more interest in these new platforms, because they really feel to me that they work really well. So this is the last slide. Thank you for listening to me, and I hope you will try to maybe run ReactNative on your blog too. And if you want to try the material of the talk, I've created a page on which there are many links. So you are able to scan a QR code, you are able to log in for iOS to be able to run my blog post on Expo. There are also the links to my website using the ReactNative web and the mobile website too. If you want to, I'll give the links on YouTube so that you can play with this. But if you want to see, there is a blog post here where you can see the demos. There is the mobile website available too. This is the page I created so that you have all the links. And also something I wanted to say is that ReactNative for Windows now has support for React navigation, so they were able to get it working on Windows. So I'd like to try to be able to do the same on Windows, and maybe it's for an upcoming talk. Thank you. This is all I got.
Thank you so much, Sébastien. That was a super cool talk. I've not seen many people do stuff like this before, so I found it really interesting. Yeah. Thanks for putting all these links, because I'll definitely be giving them a read later. I had a question though, like the first time you did all this, there was quite a few things here I've not seen before. Did you have many problems? Were there many roadblocks? And when you did, were there any good resources that you went to help?
Yeah, I had a lot of problems because no, I don't think there is any resource to be able to do these kind of things. I've seen examples, for example, of CSS in JS integrations in Gatsby, so this helped me to understand how this has to be done. And I've also seen ReactNative web examples on the web, and I try to mix them to be able to get them working together. And for the MDX part on ReactNative, I was actually, there is someone that did publish a gist with some example integration, but he didn't have the exact same approach than me. He embedded the compiler directly in the mobile application, but this is not recommended for performance reasons and maybe security too. So I tried to actually use another approach, but actually the way I do with a build step is not perfect. I think I should be able to use a Metro transformer to be able to achieve the same, but the API of Metro is quite undocumented, so it's hard to figure out how to make it work.
And what's the best way to like track your progress? So like, there's a lot of things you said next and that you're going to try and do. Do you like post on Twitter regularly, or is there anywhere I can like check back in the future to see?
Yeah, but I don't push any progress on Twitter, so if you want, you can follow me.
Amazing.
Also, I have a newsletter on my website, so if I have a blog post to publish about this, I just send an email with some updates.
Awesome, amazing. I'm not seeing any questions, so I'll let you go, Sébastien. Thanks for talking. If any do pop up though in the chat, if we've missed them again, I'll get Sebastian to go back and answer them for you guys. But no, thank you so much for talking, and thanks everyone for watching. We're going to try and we are going to do these more regularly again, so hopefully we'll see you all back next month. And if anyone is interested in speaking, just reach out on meetup.com. Otherwise, have a good night, everyone.
Okay, thank you.